fans. Welcome to Math 1. We're in section 1.1.2, and let's get started. Okay, it says a new car loses an average of $1,800 per year. When Nia bought her new car, she paid $25,000, and the expression 25,000 minus 1,800y represents the current value of the car. And then it asks, what effect, if any, does the change in the number of years since Nia bought the car have on the original price of the car? Refer to the expression. So a couple things we should notice here. There are two terms. We've got the 2,500, which this stands for the original price. And then it says it loses a value of 1,800y, which this would be your depreciation. Like they say, when you drive the car off the lot, it loses money right away. And so it looks like it's losing 1,800 per year. So now it says determine the effect that the number of years has on the original price of the car. Well, the 25,000 is a constant, so it will remain the same. In fact, that's where that word constant comes from. The only thing that will be changing is that minus 1,800 times the number of years. Okay, there. Example 2, to calculate the perimeter of an isosceles triangle, the expression 2s plus b is used, where s represents the length of the two congruent sides. Remember, an isosceles triangle has at least two congruent sides. And then you have b that represents the base. What effect, if any, does the increasing the length of the congruent sides have on the expression? Okay, so there's my isosceles triangle, and I'm just curious, if I increase the length of s, does that necessarily have any effect on b? And the answer is no. I could draw b with the same length and really have some long sides there. So what I want you to write for this one changing the length of s will not impact the length of b. S and b are independent. And finally, money deposited into a bank. Be very familiar with this expression here, and then we're going to get into compound interest. But let's talk about this. Money deposited in a bank account earns interest on the initial amount deposited, as well as interest as time passes. The compound interest can be described by the expression P, which is your principal. This is your original amount. One stands for, it's kind of like a placeholder. So if you didn't have a rate, nothing would happen to your principal, because when we multiply by 1, nothing will happen. So we always go 1 plus r. Now if it was decreasing, it would be 1 minus r. And we're going to raise that to the n power. And it basically says, how does each change in each variable affect the value of the expression? Okay, so here's the answer. Changing the value of p, if you were to change this value right here, p times 1 plus r to the n, wouldn't have any impact on the 1 plus r to the n, but it will change the expression by a factor of p. Okay, changing r doesn't change the value of p. R is that number on the inside of the parentheses, as you can see there. That's the rate. That's going to be the base that's being raised to the n power, but the rate really doesn't affect how much money you put into your bank in the first place, but it will, again, affect the overall expression. And then finally, changing n does not impact does not impact, sorry, r. Changing n does impact 1 plus r because you're raising it to the n power, and it's how many times this gets multiplied by itself. Okay, that's the lesson for 1.1.2, and we'll see you in class. Bye.